We're here in an older Las Vegas neighborhood filled with 1960s ranch houses. Houses such as this are common across the Southwest and California to the numbering in the tens of thousands. Behind me is one such house. One big difference, however, is this house has just gone under a deep energy retrofit. This deep energy retrofit was sponsored in part by Department of Energy, the Building America program, and the Builders Challenge. The Builders Challenge is a program that endorses builders to push the limits of energy efficiency further than they typically would. Generally, the number is a 30% energy improvement over code-built houses. In addition, the Building America program pushes builders to even higher levels of performance. In this case, we push the house all the way to 70% improvement over standard construction, with the 30% made up in renewable energy. One of the goals of the Building America program is to make net zero energy homes a reality. And they've set up specific metrics for reaching that goal. One of those goals is to build houses at efficiency levels 70% better than standard construction, and to make up the remaining of that energy with on-site renewables. In this case, with an existing retrofit house, it becomes even a higher hurdle to cross. We started with a house that was 23% less efficient than standard new built construction, but still managed to get 70% energy efficient improvements over what new construction would be, and to meet those the remaining energy loads with a 30% renewable. The way we reach those dramatic levels of energy efficiency is to get our energy loads as low as possible. In Las Vegas, obviously that means cooling loads, but it also means heating loads, hot water loads, and all other electrical and gas uses within the house. The first thing we have to do is go after the building envelope, the insulation systems around the house that keeps the heat out and keeps the cool in the summer, and does the opposite in the wintertime. So the building envelope, the roof, the walls, and the windows are the keys to getting our energy efficient levels down to where we want them. Let's go take a look. I mentioned the importance of the building envelope in reaching these very extreme levels of energy efficiency. And perhaps no component in the building works as hard as the roof, especially in a place like Las Vegas, where the summertime outside temperatures can get up to 110 or 120 degrees. The roof surface can get much hotter than even that, up to 160 degrees or above. So what we did in this house, in the ReVISION house, was use an extreme heat rejection strategy for our roof. We used what's called a cool metal roof, as manufactured by MBCI with association from the Metal Roofing Alliance, and put on a roof that has a solar reflective index of 0.53. What that means is the metal roof has the capability of reflecting out the energy of the sun to the level of 53% before it even gets into the roof assembly. In addition to that, we've got a vented surface underneath the metal roof with a continuous vent strip across the soffit and a continuous ridge vent. That 3-inch vented space has the capability of exhausting about 30% additional of the energy load onto the roof surface. That according to studies done by the Oak Ridge National Lab. Even with our work with the Metal Roof Alliance and MBCI on this cool metal roof heat rejection strategy, we're taking this a step further to see if we can't get even higher levels of performance with this roof. Under 2 of the roof panels, we've got thermocouples mounted, trying to see if we can lower the temperature on top of the roof insulation even further by employing a radiant barrier facing up into the vented space. We'll be collecting data over the summer, checking out the temperatures in those 2 test bays to see if that additional radiant barrier can lower the temperature of the roof cavity even further. We talked about the heat rejection strategy on the roof and the roof coverings, but we still need to talk about what's under that roof. If we're going to have a high-performance roof, it has to have high-performance insulation. And that's further complicated by the fact that this house is a deep energy retrofit. And what we wanted to do was do most of the work from the outside in, leaving the interior finishes intact. To accomplish that, we stripped the roof off, sprayed the existing roof cavities filled with 8 inches of closed-cell polyurethane foam, BASF Comfort Foam, which has an R value of 6.5 per inch. So we've got a roof insulation package of over R55, a very effective insulation package for this climate. Now, we had to do something similar to the walls, so let's take a look to see what we did over there. The walls are obviously also a very important part of the building envelope. And just like in the roof, we employed a deep energy retrofit strategy by peeling off all the exterior sheathing and siding on the house. Most of the materials were older stucco, board and batten wood siding, very deteriorated, but the interior surfaces and finishes again were in pretty good shape. So we stripped all the exterior materials off, exposed the studs and the interior drywall, and then filled those stud cavities with 3.5 inches of BASF Entertight open cell foam. The open cell foam is different than the closed cell foam we used in the roof. Doesn't have quite as high an R value at 3.5 per inch, but it was an excellent product to give us air sealing in the wall cavity and allow us to shave the insulation flush with the exterior surface of the studs. After our walls are insulated, we've got to put our exterior coverings back on. In this case, we started by putting on a layer of OSB structural sheathing. Las Vegas is in a high-risk seismic zone, and this has had very little lateral support, but it didn't fall down. We wanted to make sure that our sustainable house was in fact durable, so we added our structural sheathing to the outside. On top of our structural sheathing is a layer of DuPont stucco wrap. Stucco wrap is a drainage plane product with little ridges and valleys, specifically intended to provide a drainage plane behind the stucco so that any water that gets in can drain down and away from the building. We also used a DuPont product to caulk and seal at the sill plate to the slab. That's the one place our insulation fill does not provide adequate air seal. Another DuPont weatherization product we used on the ReVISION house is the DuPont roof liner, a lightweight product that is easy to install, durable, and effective in draining moisture away from the roof deck. After our building was resheathed and our drainage plane was applied, we came in with 2 inches of expanded polystyrene insulation, EPS, on top of the studs and sheathing. That gives us a thermal break on the outside to make sure that the wall cavity insulation is fully effective. On top of that is our Drive-It EFIS system. That's an exterior insulation finish system that really looks like the stucco that was on the house originally that we pulled off because it was deteriorated. We wanted to maintain the same look of the house. It's also a product that protects our insulation, is durable, and provides that extra energy efficiency and water protection that our ReVISION house deserves. So with our walls, what we started with was a poorly insulated, air leaky wall with deteriorated exterior siding and virtually no structural sheathing. What we ended up with was a very durable wall with an R value of R22 and very buttoned up air sealed. And the last part of our envelope package is our Milgard Ultra fiberglass window and doors. These windows and doors use a pultruded fiberglass frame, which is very energy efficient, very high U value, but also in this case is paintable, which allows us to put on a silver finish which matches the aluminum from the existing house, again staying with that 60s iconic look. The glazing here is both double and triple low E glass, and we've got a solar heat gain coefficient of below 0.2. Extremely efficient. What that means is we can block over 80% of the solar rays before they get into the house, blocking the heat before they get into the house. Additionally, the U value on these windows is 0.34 for the double glazed and 0.19 for the triple glazed. Again, very, very efficient. In addition to our sliding glass doors and our windows, Milgard also provided our custom-made clear stories, very large panels of glass, again double low E, and solar heat gain coefficient to match our sliders. They also provided the glass French doors to the entrance of the house and leading out to the back patio. When installing windows and doors, a very important part to pay attention to is how we keep the weather out. It's generally a weak link in the envelope in terms of moisture control. In this case, using the DuPont weatherization flashing system, including straight flash and flex flash, we were able to maintain an integral bond between the window web and the structural sheathing and stucco wrap on the house. Water management on the building envelope is important, but so is water management on our landscape. What we want for our landscape is any available rainfall to hit the surface and to percolate directly into the ground and recharge the aquifer, as opposed to simply running off, picking up pollution along the way, and going into a storm drain. What we've got here on our surface is a BASF perma-paved product, which is ground up granite mixed up with a polymer mixture that holds it together and binds it together, but it remains porous. Allowing the water to absorb directly into the ground without runoff. We used a similar BASF product in the front on the driveway and the walking paths. That product, Filter Pave, uses crushed glass rather than the granite to produce a similar type of surface with full permeability. If energy conservation in a house in Las Vegas is important, then water conservation is absolutely critical. Most people don't realize how much water they use in a house in a given year. It seems amazing, but true, that a typical family of 4 will use 25,000 gallons of water a year to flush a toilet, just a simple toilet flushing mechanism. If you've got 4 people in a house and it's averaging 5 flushes per person at 3.5 gallons per flush for 365 days, that's 25,000 gallons. For our ReVISION house, we've gone with the American Standard H2O option dual flush toilet. This will actually save that same family of 4 17,000 gallons a year in water. This dual flush mechanism allows a user to select either less than 1 gallon per flush or a 1.3 gallon per flush depending on need. We also get additional water savings at the lavatory faucet, like this American Standard's Moments faucet. Rated at 1.3 gallons per minute, this will save the average family 4,000 gallons per year. An even larger amount of water savings can be had by going to a water conservation shower head. The FlowWise American Standard shower head that we have in the ReVISION house is adjustable from 1.5 to 2 gallons per minute and automatically adjusts itself down to 1 gallon per minute every time it starts up, saving that same family 14,000 gallons of water every single year. So now we've talked about some of the energy efficiency features of the building envelope and some of the water saving features both inside and outside the house. Let's go talk about some of the mechanical systems and see how we meet those remaining loads. Before we started the renovation work on the ReVISION house, the building envelope was so bad that the 2 mechanical systems that provided the heating and the cooling were vast. On the heating side, we had a total of 160,000 BTUs of capacity, and on the cooling side, 72,000 BTUs of capacity. By providing all the envelope improvements, we were able to get both the heating and the cooling capacity down to 36,000 BTUs, which is a huge improvement. More importantly, we took the mechanical systems that were located on the roof and managed to install them in a small mechanical closet right in the middle of the floor plan. By putting the mechanical closet inside conditioned space, we take the huge heating and cooling loads off of that equipment that used to be sitting out in the sun. This equipment is the Trane Variable Speed Comfort Link 2 system, an 18-SEER heat pump providing both heating and cooling. This 36,000 BTU capacity system is more than adequate to meet the reduced cooling loads of our house. Included in this system is an advanced electronic filtration system to make sure that the air that's circulated through the house is filtered and cleaned before it's deposited to our heating registers and cooling registers. We also feature a direct return system with a single central return directly to the base of the unit. What this does is it simplifies airflows and makes sure that we have adequate return path back to the equipment and eventual distribution through the house. The outdoor condenser unit that this is connected to is also part of the Trane package, and it's a little bit larger than most condensing packages that you'll see. The reason for that is the high efficiency rating. The higher efficient units have to have larger heat exchanger surfaces in order to get the heat exchange process to operate effectively. Where previously we had 2 heating zones, in fact 2 complete different heating systems, we now have 1 heating system with a single zone controlled by the Trane Comfort Link 2 control system. That system, because of the better envelope, allows us to maintain better comfort within the house at far less use of energy. Another aspect of this heating and cooling system is the compact duct distribution system. The very efficient envelope with its reduced heat loss and heat gains allows us to place the ducts internally in the house rather than towards the outside walls. We get good air mixture, good air flow, and less heat loss through the ducts because there's simply less of them. When doing an energy efficient house, the heating and cooling loads are usually the highest energy uses. But when you have a very efficient house, like we do here, it's the domestic hot water that ends up being the highest use. So we've got to come up with a strategy that equals the energy efficiency of the heating and cooling for our domestic hot water. And what we did here was a two-part strategy, starting with a Rinnai tankless water heater. This tankless water heater is rated at about 85% efficiency. Compare that to the tank that was here, which was rated at about 58% efficiency. So we had an increase of about 30% just by the installation of this modulating gas tankless water heater. Our strategy does not end here, however, because this is hooked up to a solar preheat system. That preheat is a 80-gallon storage tank with 2 solar panels mounted on the roof. When I turn on a hot water faucet in the kitchen, that water flows from that storage tank through my Rinnai tankless water heater. If the water temperature is not high enough, the Rinnai will automatically turn on and boost that water up to the desired temperature and deliver it to my kitchen sink or whatever other domestic hot water use I've got involved at the time. If that water is hot enough, it'll just simply pass through without firing, increasing my efficiency. Also located in our central utility closet is our fresh air ventilation system. In this case, we use a Panasonic Whisper Green fan that's drawing 50 CFM continuous 24/7. That's called an exhaust-only ventilation strategy, which actually depressurizes the house a little bit. It's a strategy that works very well in dry climates or in cold climates. In other climates, you'd have to use a more aggressive strategy like a heat recovery ventilator, for instance. Also located in this closet is our Maytag high-efficiency washer and dryer, part of our efficient appliance package. The horizontal access washer uses about 1/3 less water and energy than a conventional washer. And again, in Las Vegas, saving water and energy are both very important. The rest of our energy efficient appliance package is in the kitchen, where we've got our Energy Star KitchenAid refrigerator and Energy Star KitchenAid dishwasher. The combination of Energy Star appliances in this house saves about 500 kilowatts a year. That represents 5% of the energy savings for our house in its completed form. The kitchen countertops in our ReVISION house are a DuPont product called Zodiac. Zodiac is a quartz-based artificial stone product that's impervious, easy to clean, easy to fit, and very, very durable. Also in the showers, we're using another DuPont product, Corian, for the shower enclosures. The kitchen cabinets in the ReVISION house also are part of the sustainable matrix in our home. Not only are they durable and beautiful, but they're manufactured according to the certified ISO 14001-2004 standard and the Environmental Stewardship Program. Both the kitchen backsplash and the floor tile are manufactured by Mohawk and contain between 20 and 51% recycled content by volume. The ceramic tile floor is both durable, easy to clean, leading to improved indoor air quality. Mohawk also provides the laminate hardwood floor in the living areas of the house. The Mohawk laminated floor uses Pure Bond technology, which eliminates urea formaldehyde binders. It also is a resource-efficient use of materials with a plywood backing and meets the stringent California Air Resources Board standards for indoor air quality requirements. The carpet in the family room and the master bedroom is the Mohawk Smart Strand with DuPont Sorona. Renewable resource polymer is made in part from corn. Production of 7 square yards of Smart Strand saves enough energy and resources to equal 1 gallon of gasoline. The carpet in the other 2 bedrooms is Mohawk's Everstrand. Everstrand is a 100% post-consumer product. Because the FDA requires such high-quality PET for beverage bottles, the recycled fiber is as good or better than fiber made from virgin resin. Another part of our efficiency package is the energy-efficient lighting. What we did is retrofitted the existing cans in the ceiling with LED cans in the kitchen as manufactured by Cooper and with compact fluorescent bulbs in the living room. Our roof insulation strategy allowed us to keep the existing can rough ends in place and foam around them with the closed cell foam. That was a savings in cost and in man hours. The overall savings for the energy efficient lighting package ended up being approximately 500 kilowatt hours per year. The lighting for the house is controlled by Lutron controls. We've got multiple control points throughout the house, including monitor keypads and remotes. These allow us to set particular room moods, given certain occupancies like meal preparation, mealtime, sunset, or entertain. We can also look at what lights are on in the house and see if Johnny left the bedroom light on, turn it off, and save energy. Other controls include occupancy and vacancy sensors in some of the walk-in closets and dimmable controls for the compact fluorescents in the living room. It's the controls that allow us to see what lights are on and to turn them off when not in use. In the family room and in the bedrooms, we also have Hunter Douglas Duet honeycomb shades. Not only do these shades provide privacy in the rooms that need them, but also a little extra protection against the solar gain in south and west facing windows. These shades also have a stringless technology that lets you lift them up and lower them with the simple touch of a finger. One of the products that's hidden below the surface, yet is very important to our ReVISION retrofit house, is the PEX plumbing. The Uponor PEX plumbing, which is the cross-linked polyethylene piping, has many advantages for retrofits. It's flexible, so it can bend around corners, allows us to eliminate elbows and joints, making for a simple, faster installation. It also doesn't require torches, something that can be a hazard when exposed wood rafters and studs are in place at a retrofit. We can eliminate water hammer and at the same time provide a product that is better for aggressive water because it's less corrosive. All in all, PEX has a lot of advantages over standard copper piping. Most of the products and technologies we talked about so far today had to do with energy conservation. And in this house, that combination of products got us to a point where we are now 70% more efficient than a code-built house and about 80% more efficient than the house when we started. But if we're going to get to a zero energy house, we need to have additional on-site renewable capability. And to do that, we installed a PV system on the roof. This PV system, or photovoltaic system, can generate almost 10,000 kilowatt hours a year and makes our house a net zero energy house. Starting with our 1960s Las Vegas ranch house, we looked at all the attributes and components that would be needed to be changed to make our house a 21st century house and perform to levels of zero energy. We looked at the walls, the windows, the roof, the mechanical systems, the indoor air quality, the water savings components, and all the other durability factors that would make this truly a green and sustainable home. In doing so, we came up with a combination of factors that let this house be truly sustainable, zero energy, and fit for the 21st century and beyond.